Hello everyone, here is a simple question of the linear momentum conservation. There is an artillery piece of mass m1, means this machine has mass m1. Inside it there was a shell, the shell had the mass m2. Okay. This artillery fires the shell horizontally. Instantaneously after the firing, we need to obtain the ratio of the kinetic energy of this artillery and that of shell. Artillery has the mass m1 and shell has the mass m2. Okay. The surface is smooth and firing has been done horizontal. So what we do, we consider this shell and artillery as our system. We consider this as the system. Okay. Now on the system, there are two forces visible. One is the normal force, other is the mg. They are getting balanced. In horizontal direction, there is no external force on the system. Surface is smooth, so there is no friction. It means in the horizontal direction, we can conserve the linear momentum of the system, as the net force along the horizontal direction on our system is 0. Now, when we check just before firing, the initial linear momentum of the system is 0 because everything was at rest. And by the principle of conservation of linear momentum, just after firing, if we check the linear momentum of the system, it must be 0. There is no external horizontal force on the system in the horizontal direction, so the linear momentum of the system remains conserved. To conserve the linear momentum, if we consider that this m2 gets the linear momentum p in the forward direction due to the firing, then this should get a linear momentum p. I am talking about the magnitude in the backward direction, because we want to keep the net linear momentum of the system as 0. So this gets a linear momentum p in the forward direction, then this must get a linear momentum p in the backward direction. I hope you agree with this. Okay. Now, we need the ratio of the kinetic energy. Let's say we call its kinetic energy as K1 and the kinetic energy of that shell we write as K2. So basically, we are going to obtain K1 by K2. There is a formula in physics. Kinetic energy is equal to half mv square. You multiply and divide by v both sides like this and rewrite this formula. It will be mv whole square by 12. And at the place of this mv, we can put the magnitude of the linear momentum p. So this would be p square by 12. So the kinetic energy can be written as p square by 12. Kinetic energy's ratio when you want to obtain, here you will write p square by 2m1, here you will write p square by 2m2. These two pieces had the same magnitude of the linear momentum. Here we can see p square getting cancelled out. We can see that 2 is also getting cancelled out. So the ratio comes out to be m2 by m1, which matches with the fourth option. So this should be the correct answer. I hope you enjoyed the solution. If you enjoyed it, please like this video, share it with your friends and kindly subscribe to this channel. If you have any other doubt in physics, please post that in comment box. We'll discuss that. Stay awesome. See you soon and thank you.